Good morning, girls. Children, I'm continuing the chapter Gravitation, and I hope you have seen my yesterday's video in which I had explained you what is the meaning of force of gravity, right? Then some examples I discussed with you to show the presence of gravity on the earth as well as the force of gravity is present in the whole universe. Like if you throw something in the upward direction, that object will fall down, and this falling down of any object is due to the presence of the force of gravity on the earth. Okay. Then I also told you that the gravitational force does not only exist on the earth; it is present everywhere in the universe. The the existence of solar system is one big example, and the motion of the satellites around the planet, okay, that is also one example through which we can understand that gravitational force exists in the whole universe. Okay, I also told you that Sir Isaac Newton, okay, gave a law, right? And I told you that today I'm going to explain you this universal law or the Newton's law of gravitation. Newton's law of gravitation says that every object in the universe attracts every other object, okay, by a force which is directly proportional to the product of the masses and is inversely proportional to the square of the distance between them. Okay, so I'll repeat the law. Newton's law of gravitation says that any object on the earth will attract the other object, or we can say that every object in the universe attracts every other object, okay, by a force, okay. That force is directly proportional to the product of the masses of what? Masses of the two objects, and is inversely proportional to the square of the distance between them. Now we can write this statement in the mathematical form. Okay, so what are we studying? We are studying Newton's law of gravitation. Suppose there are two objects A and B, okay, and both of them are separated by a distance d. Okay, now this object A has mass m1 and this has mass m2. So definitely according to the Newton's law, it says that every object will attract every other object which is present on the earth. So therefore, if object A and B are present, there will be attraction between them, there will be a force of attraction between them, and this force of attraction, which is given by capital F, is directly proportional to the product of the masses. Yes, m1 and m2 means the product m1 into m2, and is inversely proportional to the square of the distance between them. So you can read it once again. F is directly proportional to the product of the masses and is inversely proportional to the square of the distance between them. Let us take the distance between the two objects to be d. Okay. Now, if we combine the two laws, we will get F is directly proportional to m1 m2 upon d square. Okay, now let us first understand the meaning of this first part and then second part, and then we'll complete the derivation. Now, F is directly proportional to the product of the masses means if the masses of the objects will increase, okay, the force of attraction between them will also increase. This is the meaning of directly proportional. And inversely proportional means if the distance between the two objects increases, the force of attraction between them will decrease. This is the meaning of inversely proportional, and I have explained you the meaning of inversely and directly proportional in the previous chapters also. So again, if the masses of the objects will increase, what will happen? The force of attraction between them will increase. And or if the masses of the objects will decrease, the force of attraction between them will decrease. But if you talk about the second part, if the distance between the two objects increases, okay, These are two objects. If the distance between the two objects will increase, the force of attraction between them will decrease. Okay, so therefore by when we combine these two laws, we can write F is directly proportional to m1 m2 upon d square. Now, as I told you before also, that when we have to remove the proportionality sign, we have to put a constant. So let us put a constant over here. We have F is equal to, now directly proportional sign will change to equal to, and this will become capital G m1 m2 upon d square. Okay, now what is G? Capital G is the gravitational constant. Okay, so it has a specific value. So what I'll write it once again, that first I'll tell you the statement, that according to the Newton's law of gravitation, every object in the universe attracts every other object, okay, by a force. There will be attractive force. You always remember that the force which is acting between two objects is always attractive in nature. Okay, so by the Newton's law of gravitation, every object in the universe attracts every other object, okay, by a force shown by capital F, and that force is directly proportional to the product of the masses and is inversely proportional to the square of the distance between them. Okay, so this statement you will learn and you will write in your notebook. So we can write, first you can draw the diagram also, that A has mass m1 and B has mass m2. Both of them are separated by distance d, and the force acting between them is what? Is capital F. So we can write F is directly proportional to the product of the masses and F is inversely proportional to the square of the distance between them. When we combine, we will write F is directly proportional to m1 m2 upon d square. This is one and this is the second part, two parts. Now, as I told you that when we remove this sign, we change it to equal sign with a constant capital G known as the gravitational constant, and it will be G m1 m2 upon d square. So the force of attraction between any two objects in the universe is given by the formula F is equal to G m1 m2 upon d square. Okay, so if you have to find the force of attraction between any two objects, you can use this formula, right? And remember that capital G has a specific numerical value which is equal to 6.673 into 10 to the power of minus 11. Okay, Newton meter square per kg square. You have to remember this value, but when you are using this value in numericals, we will not take the complete value. We can just take 6.7 into 10 to the power of minus 11. This will make your calculations little easy. Okay, so remember that F is given by, capital F is given by the formula G m1 m2 upon d square. Okay, and what is G? G is a gravitational constant. Now since G is a gravitational constant, its value is same everywhere in the universe. Its value will not change. Remember that its value is 6.673 into 10 to the power of what? Minus 11 Newton meter square per kg square. And what I have shown you here is, if we have to use this value for the calculations, we can take it just as 6.7 into 10 to the power of minus 11 Newton meter square per kg square. And if the value is given to you that you have to use this value, then you have to use and you have to apply this same numerical value. Okay, now you know that force is measured in Newton, so therefore we can write here also that the unit of force is capital N, that is Newton. Okay, now force of attraction, so therefore any objects, any two objects, the force which is acting between them will always be attractive in nature. Okay, now this Newton's law of gravitation is also called universal law of gravitation. Okay, if you are asked to define what is a universal law, you will write the same law. Okay, so why do we say that the Newton's law of gravitation is it is also called the universal law of gravitation? Because this law is applicable everywhere in the universe. Okay, so this is one answer. I mean, this can be one question. Why is the Newton's law of gravitation also called the universal law? Because the Newton's law of gravitation is applicable in every part of the universe. Therefore, we call this law as a universal law of gravitation. Is it clear to you? So today, when you will go through my video, you will write the complete statement as I told you. You can check out your books also, and then you will write this, you will draw this figure and write this complete derivation. Okay. Now, what is the importance of this law? Like, I'll explain you the importance of this law. Or we can also say, what is the importance of the force of gravity? Does something come in your mind when I say importance of the force of gravity or importance of the force of this law of gravitation? See, number one, this law, according to this force, it binds everything to the surface of the earth. Yes? Okay, now suppose there's a table. A table is lying on the floor. So why is a table intact on the floor? Because of the force of gravity. Otherwise, if there's no gravity, then what will happen? The objects will be floating, right? Then, number two, it will not be in the it will not be intact. It will be floating. So this is what we can imagine. So it binds everything on the surface of the earth. Okay. Another importance is, I have explained you yesterday also, existence of solar system. Okay. Because of this gravity, what is the, I mean, yeah, because of this law, what we can explain that the existence of solar system is due to the presence of the force of gravity, right? Then number three, tides occur due to the force of gravity. Now you know what is a tide. The rise and the fall of the sea level is called a tide. Okay, so the rise and the fall of the sea level is because of the gravitational pull of the moon. Okay, because of the gravity of the moon, tides occur. So this is also one example of the importance of this law, or we can say the importance of the force of gravity. Then presence of atmosphere around the earth. Yes, if there is no gravity on the earth, how will the atmosphere be present around the earth? So these are some examples, or these are some we can write. If you are asked to write the importance of this law, you can write these points. Okay, there may be some more points. Rainfall, yes, very important. Rainfall. Rainfall means anything which, I mean, rain is coming down. Okay, so rain is falling because of the force of gravity or the gravitational pull. Okay, so if you are asked to write the importance of this law, the universal law, you can write these examples. Okay, these are all universal laws, like existence of solar system in the universe, tides occur in the whole. It's not only for the earth. Okay, existence of this solar system is not I mean, these examples are actually explaining you that this law is applicable everywhere in the universe. Okay, I hope it is clear to you what I'm trying to say. Tides, then presence of the atmosphere on the earth, around the earth, rainfall because of the gravity of the earth, then everything is bound or towards the, it is intact on the surface of the earth due to the presence of the gravity. Okay, so these are some points which are explaining the importance of the law or the importance of the force of gravity. So all this is given in your textbook. You will read the chapter, okay, and write this in your notebook and learn these points. These are important, and we are going to continue the chapter. So every part of the chapter is important, and this chapter is interesting also, children. Okay. Now, just one or two more points I want to discuss now. That if you are asked to write on what two factors the force of attraction depends. If you are asked to write the two factors on which the force of attraction between the two objects depend, so you will write number one, masses of the objects, and number two, what? The distance between the two objects. Okay, so these are the two factors on which the force of attraction between any two objects depends. Then there are some questions in the textbook based on this law. Like one or two questions I can just orally tell you that suppose A and B are the two objects which are separated by a distance d. These type of questions we are going to discuss in my next class, but just I'm going to tell you A and B are separated by a distance d, and definitely both of them are experiencing the force of attraction. Now the question can be asked, what happens to this force if the distance between the two objects increases by 2 times? Yes, or the question can be this is m1 and m2. Okay, now how does this force of attraction gets affected, or how does it change when the masses of both the objects are doubled and the distance between them remains the same? Okay, you know that F is directly proportional to the product of the masses. So if there is any change in the masses of the two objects, the force of attraction will also get affected. And I also told you that F is inversely proportional to the square of the distance. So if the distance between the two objects increases or decreases, then also the force of attraction will get affected. Okay, so these type of questions we will discuss in the next class. And I hope the Newton's law of gravitation is clear to you, that every object in the universe attracts every other object by a force. Okay, this force is attractive in nature by a force which is directly proportional to the product of the masses. Yes, and is inversely proportional to the square of the distance between them. And then what is capital G? Capital G is the gravitational constant. It has a fixed numerical value, and that is given by 6.673 10 to the power of minus 11 Newton meter square per kg square, right? And what else? Force is measured in Newton. Okay, so all these points today you write in your notebook. Read the chapter, read this topic. If you have any queries or any questions, you can message me, you can ask me. And I hope this part is clear to you. Okay, now some questions are there which I'm going to discuss on this topic in the next class. Okay, thank you, have a nice day.